In this video, we're going to focus on learning objectives A and D. So we're going to state relationships between scale change rules and the amplitude and period. And we'll state the amplitude and period in scale change rules given equations or images. So just kind of forwards and backwards of each other. So let's start out with this. Here we have graph A, which is y equals the sine of x. And then graph B, which is y equals 3 times the sine of 2x. My question for you is this: what is happening from the parent function of sine of x as we go to this new graph, which has the 3 in there and the 2x? Now, this works just like chapter 3 did. Remember, multiplying and dividing two equations are scale changes. So you need to remember the rules. Do you remember? Well, if I look at the equation, I know everything is backwards for the x. So the scale change rule would have been for this, x divided by 2, and it would have been the same for the y, so it's 3 times y. Now, what are the rules or the words related to this? Well, this x is a horizontal movement because that's how the x-axis goes horizontally. The y is the vertical. So it's a horizontal shrink in half, and it's a vertical stretch of 3 times. So based on that, the correct answer for this is going to be letter C, which is a horizontal shrink and a vertical stretch. I'm actually going to add learning objective C to the rest of our notes on this video in covering the graphing at the same time. Now what we're going to do in this section is we're going to stretch and shrink horizontally and vertically sine waves. Now sine waves here are images of the sine or the cosine. So the sine waves themselves can either be sine or cosine, and it can be a composition of either a translation, and if you remember from chapter 3, translation has the SL in there, that's a slide, that's section 8, or it can be a scale change. A scale change is a stretch, it's multiply or divide, and that's section 7. Now, in real life, what sine and cosine functions are is a visual graph for sound or for electricity. And if we think about it in terms of being sound, sound has a pitch of the tone that you hear. And it also has the intensity or the volume. So the pitch on here, if we look at the period, and it looks like here we have a parent function of cosine. If we look at this, and what if we took the parent function and we actually stretched it out more this way? What happens to the pitch or the tone? Do you think the sound here becomes a lower or a higher pitch? Well, the longer the period of this, the lower the pitch or the sound. On the other way, if the cosine function actually got shorter on its period and got crunched in, that's a shorter period, and you're going to have a higher pitch. So it's almost more like this would be a girl's voice, and this would represent a boy's voice. So that's what the horizontal stretch actually does, is change the pitch of a sound wave. And in terms of vocab we've been focusing on before, we're going to notice a horizontal stretch is going to impact that period of it. Now the intensity of the sound wave is how high it goes in terms of a vertical stretch. So the intensity, the word you want to know, is called amplitude. And what amplitude is, it's half the distance between the maximum and the minimum value. So if you look at it, we're used to seeing cosine being at 1 and down here at -1. So if you look at the distance between 1 and -1 is 2, but take half of that, so the amplitude here of this graph is the number 1. Now, what happens if you turn the volume up on something? If you turn the volume up, this hump here actually gets larger. So as you increase volume, what happens is you increase the amplitude or the hump of the sine or cosine function. Conversely, if you were to lower the volume, this hump would get smaller and the amplitude would actually get smaller and lower than 1. Now remember from chapter 3, horizontal stretches. Horizontal stretches, they are related to the x-axis, and if we look at sine and cosine, the stuff that's related to the x-axis, if we follow this, is the period of the function. So horizontal stretches impact the period. They're going to use the letter A to show a period stretch. And a vertical stretch on here, we know impacts the y-axis, and for us, the new vocab for that is the amplitude. And they're going to use the letter B. Now, just like we did again for chapter 3, everything in the equation is backwards for the x, and it's sometimes backwards for the y. It depends how you look at it. So whenever we stretch something, the key is this. When you stretch this graph, the amplitude could be changed and the period could be changed. It depends where the stretch is happening. So what they're going to do is they're going to have an ordered pair rule. They're going to say the stretch, they're going to say A for the x's and B for the y's. And what they're going to do is they're going to go into the equation. This is really what's going to happen to the x. It's being multiplied by A, so in the equation they divide it by A. And the ordered pair is really being multiplied by B. So what they're going to do is they're first going to divide the y by B, but they clean it up and then end up doing the same thing. So how does it impact the amplitude and period? The amplitude is actually going to be whatever the vertical stretch is. The period will change by the horizontal stretch. So if you stretch a graph horizontally 2 times, you would put a 2 in here as a horizontal stretch, and your period would now change to 4 pi. So this graph that we see right now, as a parent function that goes from here to here, if that's 0 to 2 pi, this thing is now going to be stretched from 0 to 4 pi, and that's a period change. So let's look at this example. They want us to graph this, and we'll come back and actually do the graph, but let's talk about the amplitude and period and write the ordered pair rule. So the scale change rule for this, the 5 that's sitting right there is not with the x, so it's not the x movement, it's the y. When everything is on one side, the x is backwards, the y is the same. So the ordered pair that's correct for this is the x and 5 times y. So in words, what's going to happen, there's a vertical stretch 5 times. So how is that going to impact the amplitude and period? Well, if you think of what the parent function looks like for the sine graph actually looks like this. So what's going to happen is, think about it. If we do a vertical stretch, all that's going to happen is that hump is going to raise and this hump is going to lower. So the vertical stretch on that, or the new amplitude, the formula says, is just take the absolute value of that vertical stretch, which is a 5. The absolute value of 5 is 5. So the amplitude, or the new humps, are now going to go from here at 1 all the way up to 5. So it's going to stretch up here, and then this guy is going to stretch down here. What about the period? Well, the period for sine is 2 pi. It goes from 0 to 2 pi and repeats itself. Is it going to be changed? Well, the formula says multiply it by the horizontal stretch. Here, the horizontal stretch is 1. There isn't a horizontal stretch really, so the period is still going to be 2 pi. So when you sketch this, the period length is just 0 to 2 pi, and it's just the amplitude of the humps that get a little bit higher, should be right there, more precise, and that's what the graph would look like. I want us to use the definition of amplitude just to confirm that it really is at 5. The definition said it's the difference between the max and the min. The max point here is 5, the min is negative 5. Now the distance there is 10. And now it said cut it in half, so it's 5. So you can tell the amplitude of this graph is correct. Now let's focus on this one, and I want to come up with the ordered pair rule and talk about amplitude and period again. The graph is y equals the cosine of 6x. Now the 6 in here is grouped with the x, and so we know the ordered pair rule would have to be everything's backwards for the x, so it's x divided by 6, and there's no other number out there for the y. Well, which words here does it best match up with? Well, first of all, when I see this right here, it's with the x and it's horizontal. Is it a stretch or shrink? Well, they're going to shrink it. So they're going to shrink the x's 6 times. So what I need to do is think about amplitude and period. Let me sketch the cosine for you really quick. It goes from 0 to 2 pi, and it looks like a C shape. That's a rough sketch of cosine. Now remember, the amplitude is impacted by the y stretch. So as I look at the ordered pair rule, there's nothing happening to the y's, so the amplitude just stays the same of 1. So these humps, the heights of those are not going to change. Now it is going to be stretched. It's actually going to shrink. So how do you find the new period? Well, what you take is you take the existing period, which is 2 pi units long, and you multiply it, or in this case, divide it by 6. You divide that by 6, it's pi over 3. So this graph is actually going to shrink in to pi over 3, which is roughly in here. So you're going to see this C shape totally crunch in, and it's going to become super small and look like that blue graph. So what we've seen is the period shrunk from 2 pi all the way down to pi over 3. Let's look at one more here. Consider this equation, and as you look at this, you're going to see there's two different numbers. There's a 5 and a 2. So there are two things happening to it. I'm going to write the ordered pair rule. So the S stretch. Remember, when it's all on one side, it's always backwards for the x, so it looks like it's 2 times the x's. For the y, it's just what I see, so it's 5 times the y's. Now, which one of these 4 statements best fits what's going to happen? This graph, actually, on the x, which is horizontal, so it's a horizontal. It's greater than 1, so it's a stretch of 2 times. The y goes vertically, so it's a vertical. This is greater than 1, it's a stretch 5 times. So what you're going to see is letter A. Now the best way to do this is to actually sketch the cosine function as the parent first. Remember, the parent just looks like, it starts at 1, goes to 2 pi, and it makes this C shape. So there's our parent of the cosine. What I need to do to this graph is to horizontally stretch it twice and vertically 5 times. So let's talk about amplitude and period. Well, the amplitude, remember, by formula, is just the vertical stretch. So take the absolute value of this vertical stretch, which is 5. So the amplitude is 5. That means this hump here and these key top points have to stretch all the way up and all the way down to 5. So let me actually do that first. I'm going to show you that stretch. So I'm going to take this point and stretch it up to 5. Take this point and stretch it down to -5. And this point up to 5. Now I'm just stretching it that way, so I'm still going to cross the x-axis here. If I connect these points, that green curve right there is just the amplitude impact. Okay, let's do the second thing. What about the horizontal stretch? Well, that impacts the period. So the period again is normally 2 pi. As we can see, the graph ends at 2 pi right here, but we have to times it by 2. So I come in here and times it by 2. So the new period is now 4 pi. So what I need to do is take my green graph and don't have it end at 2 pi, but it has to end here at 4 pi. So let's take this point and actually stretch it way over here, and let me just mark that as being my 4 pi right there. Now it's still going to stay right here because that's where it started. Now remember what the cosine function looks like. It starts here, goes all the way down, and then comes back up. So right in the middle it goes down. So where's my new middle? Well, if I start at 0 pi and I go to 4 pi, that means 2 pi is my middle. So this thing is going to bottom out down here, so I'm going to actually move the lower part right there. Now, between 0 pi and 2 pi, it's going to cross the x-axis right in between the middle. That's at 1 pi. And then between, here we have the 2 pi and the 4 pi, the middle is 3 pi, so that's where it cuts. If I connect these blue dots, that's going to give me the final equation. So what we've done is we've stated the scale change rule, which is literally what's going to happen to the graph. We talked about the amplitude and the period, and we sketched them in stages. We first sketched the amplitude stretch, which was my recommendation, and then come and take that amplitude stretch and take that and do its horizontal stretch to get your final graph.